What is ergonomics? Ergonomics, or as it is sometimes called, human factors, makes sure that the work environment is designed to fit human capabilities. It relates human characteristics, abilities, expectations, and behavior to the design of machines, tools, facilities, environments, and procedures. Using ergonomics has been shown to be an effective way to reduce accidents and injuries in the workplace. The Bureau of Mines Pittsburgh Research Center has a group which focuses on ergonomics research. The group consists of about 25 engineers, psychologists, sociologists, and training specialists. A study currently being performed by the Bureau is using ergonomics to determine what problems, if any, are associated with deep-cut mining, or cuts greater than 20 feet, so that corrective actions can be recommended. Tools such as interviews, accident analysis, and task analysis are being used by Bureau researchers in this study. The goal of this project is to improve safety in deep-cut mining sections by providing the mining industry and equipment designers with practical tools and work methods based on human factors or ergonomic principles. Recommendations from this project could be realized in terms of equipment changes, procedure changes, and/or training materials. This research was begun for several reasons. Data from another Bureau study found that taking deep cuts may play a role in why miners sometimes go under unsupported roof, for example, when continuous miners break down well into a cut. Also, the United Mine Workers, MSHA, and several state and local agencies wanted more information about the special safety considerations when taking deep cuts. The objective of this project is first to identify existing problems, if any, in deep cut sections. Secondly, it is anticipated that recommendations for changing the design of equipment, work procedures, and training will be made, and these changes will be evaluated. Third, contacts will be made with designers of equipment used on deep cut sections so that ergonomics can be incorporated into the design process. The first step of the project is to identify potential problems associated with deep cuts. This will be done by examining MSHA reportable accidents for potential problem areas and by observing and interviewing miners who work on deep cut sections. Results from this initial information gathering are then used to develop task analysis procedures. The task analysis will be used to examine potential problem areas more closely. Once any potential problems have been identified, potential solutions, such as equipment redesign or work method changes, can be developed. These changes are then evaluated to make sure that they're practical and effective. This information will then be given to the mining industry through seminars and publications. Some of the most objective measures of mine safety are the frequency and severity rates of mining accidents. An important part of the research to look at the safety of deep cut mining has been an evaluation of mine accident data collected by MSHA. In particular, accident data of mines that had MSHA approval to take deep cuts has been compared to accident data of mines which did not have approval to take deep cuts. The analysis focused on small mines, those less than 50 employees. Furthermore, the analysis didn't include mines with longwall sections, since these sections are so different from continuous mining sections and may bias the results or wash out any differences. The analysis only included injuries which resulted in lost time or were fatal in 1990 and 1991. There are some limitations with the analysis. First, we don't know if a deep cut was being taken at the time of the accident, only if the mine had approval to take deep cuts. We assume that deep cut mining is more prevalent at mines with deep cut approval. Also, the existence of longwall systems and mine size influence accident rates, and we have looked at these factors in our analysis. There are other factors, though, which also influence safety. These include mining conditions, seam height, geology, the type of ventilation system used, the makeup of the workforce, and the management structure. So these results are only generalizations and cannot be used to make inferences about specific mines. However, these results may provide insight as to the nature of accidents in deep-cut mines, so follow-up studies can be performed. The first step in the analysis was to see how accident statistics vary according to mine size and according to whether the mine had approval to take deep cuts. Then, small mines were examined to see what kind of accidents were occurring in deep-cut and non-deep-cut mines. Specifically looked at were the type of accident, the worker's activity, and the job titles of those injured. These results do not provide us with complete information, but do provide us with areas to further look into with other techniques, such as interviewing the workforce and using task analysis. On the average, deep-cut mines tend to be larger than other mines. In fact, mines with deep-cut approval report more than 3 times the number of employee hours per mine than mines without deep-cut approval. This fact highlights the need to normalize the number of accidents to exposure hours. Any analysis that doesn't may be misleading. The overall fatality rate of mines with deep-cut approval was about half that of mines without approval, 0.05 versus 0.1. These rates were similar within each size category, though. This implies that mine size is a more important factor than deep-cut approval status and its effect on fatality rates. Mines with deep-cut approval report a slightly higher accident rate than those without approval, 14.17 versus 12.47. It appears that mine size played a significant role in this difference as well. Larger mines reported lost time injuries at a higher rate than small mines. Now, let us look at the type of accidents found in small mines, broken down by deep-cut approval status. In small mines, handling materials was the largest single category of accidents, accounting for more than 30% of all accidents. Deep-cut mines had an almost 20% higher rate of reported material handling accidents than did non-deep-cut mines. One possible explanation for this statistic is that as deeper cuts are taken, the trailing length of continuous mining machine cable is longer, so the length of cable to be handled is longer. The longer cable is more difficult to move and is more likely to result in an injury. This figure also supports this explanation by showing that moving cable is associated with a 26% higher incidence rate in deep-cut mines. The accident rate due to handling supplies also is higher in deep-cut mines by about 22%. Slip and fall accidents have a substantially higher rate in deep-cut mines by about 82%, but these accidents only account for about 7% of all accidents in small mines. These are all areas for further investigation through task analysis. According to